Now first, ladies and gentlemen, I would like to invite Professor Dr. Jamil Ahmad, Chair of APAN Conference and Member ID at the Higher Education Commission, to welcome the guests and initiate the APAN Conference Plenary.
Bismillahirrahmanirrahim. Respected guests, distinguished keynote speakers, vice chancellors, colleagues from EGC, ladies and gentlemen, assalamu alaikum and good PC. And for making this event a memorable one for all of us. It gives me immense pleasure welcoming you all on the behalf of EGC and the entire APAN community. I also welcome those who are attending this conference through the video links. Your presence, whether virtual or physical, underscores that the importance of the work that we do together. I am very thankful to the keynote speakers for taking out time from their busy schedules, and I'm also thankful to the conference chairs and the reviewers and the organizing committee, the member of the organizing committee, and especially the audience that you have taken time out of your busy schedules and crossing all the blockages on the road in Islamabad is because of the Bangladesh team that is here in the same hotel, and that is because the security, normally what the cricketers when they come, we give them a state head security level, that is the highest level of security. And there's another thing that they also beat Pakistan for the first time. So that was another sad news for the Pakistani cricket team, but good for the cricket anyway. So I'm really thankful to all of you, and especially chairs, the conference chairs, Dr. Opal, Dr. Daimanati, Dr. Roshan, Dr. Ayasata, Dr. Ihtisham, and Ms. Jamil, for their outstanding contribution to make this event successful. I am also thankful to the collaborative institution, that is the University of Sardinia and the Educational Research Network of Sri Lanka, that is known as LEARN. So I'm thankful to the institution, they actually supported us. We actually received 46 publications, 46 papers, and out of which only 15 papers were accepted to be presented in 3 different sessions, parallel sessions, that covers important topics of computer vision, artificial intelligence, focusing on the natural language processing and data mining and pattern recognition. So these are the important topics, those will be inshallah covered during today's conference. As you know that these are very important topics, AI and HPC. They normally go together as well. That's why the slogan of this conference, they go together. So we cannot implement AI without high computational power. When we were doing our PhD in the 90s and mid-90s, we had a serious issue with the power of the computers. When I was doing my PhD, my work mainly was mathematical converting analogous algorithm to digital platform, but I had to test them with some data, and I took the pattern recognition problems. I can remember that I tried to scan digits from 400 people. I actually physically take their digits, the written digits, and scan it, and then convert it to data sets. So I created 400 data sets. So I was like a champion in my group that creating 400 data sets that time. And then when I took it to the computers to simulate it using C language, C++, the VX11730 machine, that was the highest machine available at King's College London. I used it. It took 72 hours to just simulate one data set, consists of 10 images, like 0 to 9 digits. And it took 72 hours. And you imagine if I was training my neural networks with around 400 sets. So it took many, many weeks to train the neural networks. But thanks to the King's College, the computing center, and the facility they had that time, state-of-the-art facilities, and we did not have any issue with any load shedding, anything like this, or anything is breakdown and so on. Later on, I can tell you a little bit story about the AI as well, because I'm a student of this discipline. Actually, this discipline started 140 years ago with the work of William James, a famous psychologist, American psychologist. He started, actually he mentioned in a paper which was published in 1890, it is available even now on the internet, and he mentioned that if there are two brains in succession, if there are two brains together, like I'm talking to you, you are talking to me, it means two brains are in succession, they are learning from each other. So this was his theory that time, and later on a number of people, they work on it, and especially the major work was done in the era of 1940 to 50. John von Neumann, that you might know, many of the computer people, they must know him, for the computer architectures. Actually what he did, he created the digital memory. That was the major breakthrough in the computer science discipline. And his student, after his death, published a book with the name of, I think, Brain, Mathematics, and Machine, something like this. This was the title of that work. Was published in 1949 sometime. And what he came up with the idea how to actually create a digital memory, how information can be stored in digital form. So that was the idea, but that was totally mathematical. There was no machine, nothing, no hardware behind it. And in those days, John Macaulay and Pitts, these are the two very famous researchers. They contributed a lot to the artificial neural networks. And they came up with a model, how a neural networks, or how artificial models should be, using the digital memory concept. So they come up with a model that is known as Macaulay and Pitts model. It's available even now in the literature. In those days, again, there was another psychologist, Donald Hebb. He actually wrote a book, and that book is on organizational behavior. You might know the organizational behavior, which is an area of the HR, actually. So he wrote a book on the organizational behavior, and that book, he actually specified how a learning can take place. And that book I read maybe many times, referred to in many of my papers as well. You will not find a single mathematical equation in it. But he actually gave the concept of learning, how the learning actually take place. And he took the idea of William James, that he taught that brain consists of many cells. This was his assumption, which was true later on through the microscopic study of the brain. And he mentioned that if there are two neurons in a succession, and they should be in a succession, because if it is one side in the brain, there are cells, they must be connected to each other. That's what he was assuming. And those neurons must be learning from each other, activating each other. So the activation, you might hear the activation function that comes with his idea. And now you can see a number of models available on Hebbian model, known as Hebbian models. This is another stream in artificial neural networks. And then that work was going on. Many people, they work, I know name of some of them. I even met some of them. I'm now too old, now almost cross my 60s, so I met most of these people, a number of Nobel laureates during my student life, and here to them while they were speaking in the conferences. So another scientist, and he actually, that was the major invention in artificial intelligence, Frank Rosenblatt. He actually created an actual machine, a machine which can recognize items, which can recognize images. And he was connected to the US Defense. He created a machine with the name of perceptron. So the name of perceptron actually came for the first time in 1957-58 with the work of Frank Rosenblatt. What he did, he created a machine to actually recognize submarines. And that was quite successful. But that was a binary machine. The work was going on in 1967 to 1969. Another two scientists from MIT, that name, one is Minsky and another is Papert. I met one of them, and they actually wrote a book on perceptrons. The title of the book, which is also available on net, and you can find it in the research databases as well. They wrote a book and criticized the artificial intelligence and the entire discipline, and actually they mentioned that this is a linear model. This can only recognize linear images. It cannot recognize non-linear data. And that was, they convinced people, and especially the funding agencies, those were convinced, and they stopped funding artificial neural networks and so on. And then we call that time the dark age of artificial intelligence was started in 1969 to 86. In 86, then another group from MIT again, PDP, that is called Parallel Distributing Processing Group. Vimal Hart was the main person. He actually led a group of 6 scientists, and they came up with a model. And then they mentioned that there was no mathematical problem with the perceptron, originally invented by Frank Rosenblatt, but the problem was with the architecture. The architecture they were using, that was single-layer architecture. So the multi-layer architecture actually came into existence in 1986 and 87. And then there was a conference, first conference on artificial neural networks arranged by IEEE in 87, then 89, and so on, in 92, and so on. This was going on. They wrote a book again. Then again, Minsky and Pepper, they came again and they wrote another book now. And in this time they said, okay, that time we were mathematically analyzing it, but now since the architecture has been changed, it can work, and they dedicated their book to the memories of Frank Blatt, because he was then, that time he was not alive. So this was a story of artificial intelligence, how it started, how it went to the dark ages and so on. In 86 and onward, then people, they start working on artificial intelligence and neural networks. We at the King's College London were working on the PRAM, RAMs based on the probability. Our group was mainly involved with the mathematics. The group actually invented a machine as well that's called Wizard. They were a machine to recognize images and iris and so on. Anything, image, even videos, and those were possible to be recognized with the machine. Wizard is the name of the machine that is actually dedicated to them, the name of a number of scientists. So that machine was applicable to some data in the control environment. And later on that was taken by the Imperial College London and become actually a number of algorithms, a number of models have been created based on that machine from King's, Brunel University, and University College London, and Imperial College, and so on. And that was going on. But in 2000, early 2000, then people have realized that it's very difficult to simulate artificial intelligence model, because there were 3 actually serious issues at around 2000. One was with the data sets, the availability of data, that was one issue. The second, the power of the computation. And the third was a little bit problem maybe with the architecture as well, because the multi-layer architecture that was invented in 86 was very costly in terms of computational power. It was very difficult to use 2-3 layers in the middle. It was only single layers was usable. If you use 2 layers, it was not possible to simulate. So then these 3 problems, the architectural problems, power of computation, and then the data sets. So with the invention and with the advancement in the hardware technology, like in the APAN GPUs, now HPC, and so on, and with the availability of data, big data science, data analytics, and so on, those 2 problems have been solved. And there's only one problem was left, that was with the architecture. That was solved through the deep learning architecture, convolution networks that was invented. And that's why you see now a lot of people, they're applying artificial neural networks because of those 3 problems. Those were the main hurdles. When those problems were finished, then there's many applications available now. One is in the form of ChatGPT, that is one of the best example, and there are many examples now coming up. We at the GCS are planning to create a data center at Lahore in Karachi. In one of our data centers in Lahore, we are also planning to have HPCs and cloud, HPC cloud. So very soon we will have our own HPC at Lahore. All of you, the universities in Pakistan, will be connected to it virtually. It will be connected virtually, and they can have virtual machines at their premises, and when they use and finish with it, it will go back to the center. Similarly, we will have our clouds, our own clouds, HEC clouds. The data will not go outside. We are also planning with the firewalls hardware-based, software-based, that will cost us something $8 million that we are spending on the firewalls to protect the data. So your data, whatever data you put there on the data centers, on the HEC data centers and cloud, it will be totally protected. Nobody would be able to see it except the users, if the user allows it. Otherwise, nobody would be even able to hack it or see it or view it even. So this is what we are planning at the HEC. We are also coming to this fund that is also we are optimizing from fund as well. Right now we have 3 rings in Pakistan, 3 major rings, and we are now working on the western route that connect the Quetta and Karachi, DA Khan, those areas where we have launched a major project of 800 million rupees to optimize some of the links there. We are coming with some cost models as well, effective cost model to reduce the cost of the connectivities to the universities, and many good things, inshallah, are coming. Anyway, I would not take much time. I didn't want to take much time because there are, we have keynote speaker, outstanding keynote speaker with us here. They will be talking about the HPCs and AI in detail. Once again, ladies and gentlemen, thank you very much. But at the end, I would like to thank the sponsors. There's a number of people. This conference, this event would not be possible without the sponsorships of many people, especially Huawei. I'm so thankful to Huawei to be the partners with us in this event. And not only with this event, but I'm thankful to Huawei for their support to the advancement of technology in Pakistan. I'm thankful to other sponsors, TMC, DWP, Comtel, AFS, SNAP, Lenovo, PTCell, APNEC, Transwords, NRTC, DAWA, and the important one, the APAN. The APAN, thank you, APAN, for allowing us to hold this conference here in Pakistan. This is 58th conference, and I hope in future again we'll be arranging such activities and conferences. Thank you. Thank you once again for being with us at this great day, and I look forward to the productive discussion and meaningful exchange of ideas during this conference. Thank you very much.